Hello everyone. In this short video, we will talk about chi-square-test and the requirement to apply chi-square-test. And we will learn how to do chi-square and fisher-test in R. So, chi-square-test, also known as test of independence or test of association, is a non-parametric test that tests if two categorical variables are related or not. So our null hypothesis is there is no relation between the two categorical variables. It only compares categorical variables. It cannot compare continuous variables. And it only tells if the two variables are dependent or independent. It cannot tell the type of relation between the two variables. So let's start with what is contingency table. So contingency table is a table with at least 2 rows and 2 columns, and it's used to present categorical data in terms of frequency counts. So imagine we have a survey study and we want to study the burger type preference between male and female. So we have 3 choices: beef, chicken, and veggie burger. After we collect the data, we want to convert our data table to contingency table to be able to make sense of the data. So we will have 2 rows and 3 columns. We have the male and female, and we have beef, chicken, and veggie burger. So now you collect your data, you built your contingency table. We need to understand the requirement to apply chi-square test. So the first requirement to apply chi-square test is to have two categorical variables. We mentioned in our previous example, gender and burger type. The second requirement, each variable should have at least 2 groups. So you cannot have in gender just male. You need to have at least 2 groups, male and female. The third requirement, there should be independence of observation. So what independence of observation means? It means that within the subject, there should be no relation between the subject in each group. For example, you cannot count a person twice, and selection should be random. Between the subject means that the variables, they should not be paired. For example, pre and post test observation. The fourth and the last requirement, you should have a large sample size. So the expected frequency should be at least 1 for each cell. For example, in this cell we have 2, it's acceptable. But if it's 0, it's not acceptable for the test. And the expected frequency for the majority, 80% of the cell, should be at least 5. So here the majority, they are more than 5, which is acceptable. So we have only one here, less than 5, but it's not problem because the majority, they are above 5. So if the sample size is small, we need to use Fisher exact test instead of chi-square test. So Fisher exact test is similar to chi-square test, but it's used for small size samples. So now let's go to learn how to perform chi-squared and Fisher test in R. So to perform chi-square test in R, we need to use chi-square test function. And similarly, to perform Fisher exact test, we need to use Fisher test function. So first we are going to download a dataset from GitHub, treatment of migraine headache. So this is the table. And in this table, we have 4 factors, which means that categorical variables. So in exercise 1, we are gonna convert the data table to contingency table, then apply chi-square test. And exercise 2, we will directly perform chi-square test from the original data table. So let's go to RStudio. So first what we will do, we will assign the link where the dataset is available to URL. So, and then we will assign the destination, we want our file to be downloaded and name it as data to destfile. Now I'm going to use download.file function to download the file into the destination file. So let's run the command. Now it's downloading, it's finished. So let's read the file. So the file is CSV. So we are using the read CSV function. And also we are going to view our table. So let's run the command. And now our table is here. So in exercise 1, as I mentioned, first we will convert the table to contingency table and then apply chi-square-test. Here we are going to determine the relationship between the sex and the headache. So I'm going to use the table function to obtain the contingency table, and we are going to print it. So here we have the male and female, the ones they have headache and the ones they don't have headache. So let's apply chi-square-test, and here the p-value is 0.8, which is more than 0.05, which is not significant. So these two, they are independent, the sex and the headache. So in exercise 2, we are going to directly access the sex and the migraine type and apply chi-square-test. So here the p-value is way less than 0.05, which is significant. So it means that these two variables, sex and the migraine type, they are dependent on each other. So if your sample size is small, you can apply the Fisher test by using the Fisher test function, exactly similar to how we did with the chi-square test. Just change the function, and here we have the p-value is similar to the chi-square test, because here our sample is large, so it does not affect our outcome. So we covered everything about chi-square test. Next video will be about linear models. Thank you for watching.